Hello, in continuation with the digital education initiative, here is another lecture from subject VLSI technology having subject code KEC 50053 and the topic for today's lecture is photolithography. I am your faculty Sangeeta Mangesh from Department of Electronics and Communication Engineering, JSS Academy of Technical Education, Noida. The content for the lecture include the process steps, precautions and safety measures what you are expected to carry out or you have to keep in mind when carrying out the process of photolithography, and the performance merits. The instructional objectives or the expectations from the students after learning this lecture include they should be able to explain the role of photolithography and different like in the IC fabrication and different steps which are involved in photolithography, their role also they should be able to explain. Then they should be able to explain the projection systems and compare the projection systems which are involved in the photolithography process. So, what are the process steps? In the previous lecture, I have given you the introduction to the photolithography process as a whole. That means, it is basically a process which is helping you to transfer the pattern onto the wafer. So, whatever you want to write onto the wafer, and I also gave you the example that how many masks are to be made by giving you or illustrating you simple CMOS circuit. If you want to write the pattern or if you want to generate or develop this particular circuit in the form of integrated circuit, then whatever number of masks are required, that also illustration I had given you in the last lecture. So, in continuation with that, we are now going to, and I had also given you idea about the masks, different masks which are being used, then I have given you exposure to the photoresists which are being used and the role of photoresist. So, in continuation now we are going to study different techniques ahead of it. So, the first technique what we are going to study is the wafer cleaning. Like why there are these are two demarcations are being done as these are the initial or basic things and these are the advanced techniques which are in addition to the basic techniques. Over a period of time people have come forward or suggested the new techniques also for improvement or enhancement in the end results, and in order to get better in end results some of the additional processes have been incorporated. So, that is why you are having two sets of what you call steps being mentioned in this particular slide. So, first after cleaning the wafer we have seen we clean the wafer so that there are no impurities onto the wafer, then we carry out the dehydration bake to remove the moisture content, then we spin coat it with the photoresist, then we carry out the soft baking. Now, this soft baking is basically to ensure that the photoresist is properly clinged or properly get layered onto the wafer, and the adhesivity or the sticking ability, it is properly stuck up, it is properly what you call lying onto the surface, covering the entire surface, and the property with which they are two bound together or the binding property is properly maintained or is precise enough, so that no scratch or no extra pressure can eliminate any of the surface part. So, you have to ensure that there is proper binding, proper adhesiveness to the or that particular thing is properly adhered onto the wafer surface, and for that reason you carry out the soft bake. Then we have something known as alignment exposure, that is you will be using the mask align and properly mask alignment has to be ensured, so that the area is exposed to the source or light source with which you are carrying out the lithography, and post exposure there will be changes in the photoresist, and accordingly you will develop that photoresist or eliminate the unwanted portion. Then you carry out the inspection of the pattern and you carry out the hard bake. So, these are the basic steps. Now, post exposure also sometimes or these days you carry out additional baking process prior to development. So, that why do we do that also we are going to see. So, let us proceed. So, first we carry out the cleaning. Now, this cleaning is basically done by RCA cleaning method, through which you carry out chemical cleaning then you carry out the DI water rinsing, and subsequently you dry the particular wafers or set of wafers, batch of wafers using ultrasound dryers, or making them exposed to what you call rotational movement, so that with the centrifugal forces all the water particles get dislodged. So, this is how you keep on or you carry out with the what you call cleaning, first set of cleaning. After that you remove the moisture and then coat the material with the PR. Now, prior to PR also many times there is additional method, as we have seen, there is a primer which is being put onto the wafer, and then you apply the PR, so that the adhesivity is further enhanced. So, this is also one of the additional thing what is incorporated. Then we carry out how this particular primer is applied. This particular primer is applied after placing the wafer onto the vacuum chunk, and you are having the PR being released from this particular nozzle, and the extra this one will be automatically eliminated, and with initial speed to be very less, around 500 rpm, the wafer will be rotated. This PR will be released from the nozzle. Remember, the viscosity of the PR is an essential thing which is to be controlled. As the PR has got different materials, it has got one of the material which is making its viscosity proper, apart from light sensitive material and the resin. So, the viscosity is properly maintained, so that properly the material gets spread over the entire wafer with the centrifugal force. Now, this is how your PR suck back is excess of PR is sucked back, and it is basically a dispenser nozzle. Here you are you are placing the wafer onto the chuck, and it is ensure that the wafer is properly stuck up onto this particular chuck with the vacuumized system. Automatically the wafer will be held strongly, and with spindle it will be rotated. The PR will be released through the nozzle at the center, and with centrifugal force of rotation the PR will be automatically moving outwards, and slowly it will cover the entire wafer surface. So, this is how desired thickness, unless and until you get the desired thickness, the PR will be rotated and entire then slowly you increase the speed of rotation, so that proper layering is formed throughout the wafer. Now, you do not want at the edges the beading, you do not want, or you do not want the right angle at the edges. So, here you carry out the front and back edge bead removal. That means, whatever edges are there you try to soften them, and then after softening the edges basically you carry out the soft bake. Now, this soft bake is basically to evaporate the solvents which are available in the PR, because viscosity to maintain the viscosity you are having some solvent into the PR, and you do not want that PR to, you want that PR to be dry completely, and therefore you eliminate the moisture content by soft baking. This soft baking is very important, because this way is like you, depending upon the PR you have something known as the baking time and the temperature. The temperature is very moderate, around less than 100 degree basically, very because silicon is a very brittle and what you call like carefully to be handled substance, you have to take care while handling the wafers. So, you have to increase the photosensitivity to maintain the adhesiveness, you carry out this soft baking. If you over bake, that is additional like you whatever you want, and apart from it you excess bake that particular method, the PR will get polymerized and it will become less sensitive. If you bake it less than the desired value, the adhesivity will get affected, and thereby the exposure results will get also hampered. So, whatever equipment what we are going to use for soft bake is hot plate, then infrared or microwave or simple oven, where you will elevate the temperature and carry out the or eliminate the moisture content. Post exposure and eliminating or post soft bake process, you have something known as the real exposure or light beam exposure what you call technique, and this particular technique has 3 different ways, or this projection system is of utmost importance. It is the key feature of any photolithography. Now, what is this key feature? Depending upon the mask placement, how you position the mask onto the wafer, you have 3 different techniques. One is known as contact printing, second is known as proximity printing, and third one is known as projection printing. As I always tell you, no need to mug up, the names itself are the self explanatory. How? Contact means what? The wafer and the mask both are in contact with each other. When they are in contact, naturally whatever is the image getting formed will have perfect alignment, the image will be properly written, whatever is available pattern marked onto the mask will be automatically with great precision will be written or imprinted onto the wafer surface. So, this is the best technique, and minimum feature size up to or less than 1 micrometer can also be attained using this kind of technique. But then what is the cost you have to pay for this particular technique? You are handling the mask, or the mask is coming in contact with the wafer again and again, and there is deterioration or degradation or too much handling of the mask will that can damage the mask, or too much handling of the mask can degrade the performance of the mask, wear and tear will happen much faster. Okay. That means, when you are putting it very close to the surface, you are getting best results, but always when you want to attain something, you are going to lose out on the other end, and that loss is basically the degradation or too much handling of the mask, too much close proximity or too much close what you call spacing or direct contact with the wafer may damage the mask or degrade the mask performance because of the wear and tear. You are handling too many times, so it may happen that the emulsions, or already masks are basically, what are the masks? Mask is basically a transparent plate either of glass or some material which is having fine thickness, and to have the opaqueness, either you carry out what you call emulsion coating onto it, or for a precision you coat with chrome. So, either chrome coating or emulsion coating coated masks you use. So, too much handling can develop scratches onto them, too much handling can have some chrome portion getting eliminated. Another issue is basically whatever contamination on the mask is, that will get transferred onto the wafer because it is directly coming in contact with the wafer. So, these are the 2 problem areas, or these are the 2 issues related to your contact printing. Again I am saying contact printing is mask is in direct contact with the wafer. Now, let us check out. So, to overcome that, you are having another. Now, this is what is the contact printing, where mask is directly in contact with the wafer, or PR. Now, second, here you are having a smaller distance. Now, this distance is approximately you have fine distance which is available, and this distance here it is around 10 micrometer. Now, it is in proximity, proximity is nothing but close. So, here you are having closely placed mask onto the wafer surface, and when the mask is closely placed, you are overcoming the wear and tear issue, agreed. But then you have another thing or another cost to pay, that is, please understand, whenever you have simple shadow also, so shadow of the light will be depending upon the position from where the mask is being placed. So, naturally the area or the image which is getting formed onto it will have degraded resolution, it will not be exact replica because of the gap. There can be shadow impact, or there can be some issues, the resolution of printing will not be as good as it is in the contact printing. So, this is what is the cost you have to pay for this. So, that means your resolution can get compromised. So, if you are transferring the pattern of larger sizes, this can be very useful, your mask performance can be you can improve, or wear and tear you can restrict, but then you have to pay the cost of resolution compromise. Then comes the third, this is what is okay. So, you have contact and proximity being shown again in this diagram. Here you are having the light source, here you are having the lens, and your mask is directly placed onto the wafer. So, naturally because of the direct contact, the rays will directly reach to the wafer and reach to the PR, and the exposure will be proper. So, resolution will be best. What is the resolution? The ability to reproduce the exact pattern onto the mask, onto the PR surface. So, basically your wafer is coated with PR. So, you want same to be printed onto the PR surface or coated surface, and that is what you are going to attain with this. So, when you expose this automatically, now here you are having a small distance. So, naturally any angular motion or any shadow effect can hamper the resolution, and that is why proximity printing is having lesser resolution as compared to your contact printing. Then comes the third method. So, this is what is the advantages and disadvantages. So, basically when you have contact printing, I told you it is an inexpensive equipment, you have good resolution, better resolution, or good to moderate or better you can say, but limited by the resist thickness of 0.1 micrometer, and the contact, continuous contact can degrade the mask, it can develop pinholes, it can develop scratches, okay, and the particles or the dust can directly image onto the wafer. Similarly, bowing, that is the wafer bowing or local losses of the planarization can result directly onto the uniform resolution due to mask wafer gap variations, and there is no magnification, you cannot magnify, exact replica you will have to prepare or get pattern will be formed onto the wafer. So, you cannot magnify the pattern. Then the advantage or disadvantages of proximity printing. The resist, the mask is close to the photoresist coating, you can have magnification to some extent, it is inexpensive equipment, but then your resolution is getting compromised. Diffraction effects can limit the accuracy of the pattern transfer, it is less repeatable because than the contact methods, and there is limited magnification or absolutely no magnification can be possible because there is hardly any distance. Then comes the third and the most precise one, which is having both the advantages of proximity as well as contact printing, and that is known as projection system. Just like we all have our LED LED projection systems, you have all have seen the classroom, you have whatever is being projected onto the screen, or you have cinema projector. So, similarly here also the light projecting system is incorporated to project whatever is there onto the mask. Now, this projection system, see, you are able to maintain proper distance also, you are able to have you can have you are able to focus it from the distance also, that means degradation of the mask is also taken care of, that is you are protecting the mask life also. Then the system is so properly or precisely developed that there is no shadowing effect and there is no diffraction, like you have all the things precisely controlled. Only drawback is it is an expensive system. Now, the mask image is directly projected, you have ability to magnify the image or whatever is on the mask, you can magnify it, and this magnification facility is very beneficial when you are doing multiple tasks at the same with using the same mask. So, you need not have to prepare mask again and again, you can focus, or if you need the same what always in VLSI you optimize small cell, one single cell, and like a block printing you keep on imprinting the same cell onto different wafer, onto the wafer surface. So, here also, and here you have added advantage of magnification of this. So, this is the best thing which is being used. You have very high resolution, up to 0.007 micrometer, or you can have very good resolution better than that. So, scaling issues also can be addressed. You do not know contact with the mask, then mask life is saved, mask defects and other things are also reduced. You do not have any impact of the, because it is directly projecting through the pattern through the distance. Disadvantages, it is an expensive thing and complicated equipment, but you have basically, depending upon the pattern transfer or the accuracy of the pattern transfer, the diffraction effects can limit the, or the light source which you are using can limit the performance. That is only the drawback. Now, what are these? See, this is what is the being seen here. If it is a contact printer, you are getting exact formation of the image, because the image is, the mask is in direct contact with the surface. If it is a proximity printer, you will have some diffraction effects, but the image will be close to the original one. If it is a projection printing, then you will have this kind of method, you will have diffraction issues, but then the image will be produced like this. So, this is what is the difference, or this is how the what you call projection systems have been compared in a single diagram. So, contact printing is the best, but you have to pay the cost of your, you have to sacrifice for the particular mask. Projection system is the best one, but it is an expensive. Proximity is intermittent between the two systems, and this is how the methods, three methods have been used suitably depending upon the type of what you call pattern you want to transfer onto the surface. Now, after exposure, you have one more method in latest technology, or in today's or recent days, you carry out post bake also, post development. Now, what is this purpose for this is basically it is used, or you are using a hot plate for 110 to 130 degrees for 1 minute. It is very for small duration, just to ensure that the post bake, basically it is higher than the soft bake process, but it is basically to ensure that whatever your exposure has happened, that exposure many times creates problems in the area, especially when the exposure is basically, what is it doing? In case of negative photoresist, when you are exposing, the photosensitive material is comprising of polymers, and these polymer chains become strong, and because of strength increase in the strength, the multiple chains getting formed, the molecular structure becomes heavy, and therefore, the material or PR becomes strong. Whereas, in case of positive photoresist, the resin loosen, or the bonds break which are available in the resin, and therefore, the material gets easily dissolved. Now, in case of negative photoresist, what happens is, since the when you are exposing it, the surrounding area where the linkages or what you call chains of the polymers have become strong, though that area also gets hampered, and there is many times, if your area is rectangular exactly, it gets swollen by sides, and this swelling effect can reduce the performance, and therefore, you carry out such kind of baking. If you carry out, you ensure that the polymerization effects are not going to hamper the what you call etching in subsequently what is being happened, or development process which is happening subsequently. So, developer basically is dissolving the softened part of the photoresist, and the pattern is transferred onto the material. Now, you know, there is exactly like alignment is to be carried out in this case. So, basically you are carrying out and therefore, to have precise alignment of the pattern with the mask, or whatever pattern is getting transferred onto the mask, you ensure the purpose of you ensure that your what you call photoresist pattern once get transferred is hard baked and made strong enough, so that the reality pattern gets exactly reproduced as that was available on the mask. It evaporates all the solvents which are available in the photoresist, it improves the etch resistance, it improves the adhesivity when subsequently when you are carrying out subsequently the developing through etchant. So, it will improve the etch resistance, it will not get dissolved into those etchants, and then it will stabilize the photoresist, cover up the pinholes, and this is how it will. So, this is what is the PR, you are exposing it, and when you are exposing it, this is the positive photoresist. So, naturally this portion got weakened, and when you dissolve it, this portion will automatically get dissolved, this portion will get dissolved because it was positive photoresist, the portion got dissolved and the pattern got transferred onto the wafer. So, this is how we have studied all the processes starting from starting from soft bake, then we have studied PR coating, prior to that we saw primer coating, then PR coating, then exposure, and in that exposure we saw 3 basic exposure systems which include contact printing, proximity printing and projection printing. Subsequently, we saw the hard bake process, which is post exposure bake, to ensure that there are no moistures content available onto the, like whatever solvent is there, that gets automatically eliminated, and the exact pattern or the hard pattern is of PR exists onto the wafer surface for subsequent processes to be carried out. If your concepts related to these are clear, you will be able to answer these questions. That is, you should be able to answer the role of primer coating, soft bake process, exposure technique and the hard bake in photolithography. So, primer you do for improving the adhesivity, soft bake you carry out again to improve the adhesivity of the photoresist, exposure technique you carry out to improve or transfer the pattern, so that through exposure the properties of the PR will change and the pattern will get successfully transferred. Then hard bake you carry out post exposure to ensure that the properties of the photoresist remain good enough, so that subsequent processes can be effectively carried out and the pattern, which desired pattern, can be encrypted or it can be reproduced onto the wafer surface. So, if you are thorough with this, we will proceed further with different techniques of photolithography in the next lecture. So, good luck and God bless. Thank you.